Welcome to Laboratory Experiments in General Chemistry. Today we study Unit 4, Reaction Rates. First is the introduction. Chemical kinetics is the study of reaction rates and reaction mechanism. Some reactions, such as acid-base or precipitation reactions, occur instantaneously. However, other reactions, such as the rusting of iron, occur very slowly. Therefore, understanding the factors that affect reaction rates has important biological, industrial, and environmental significance. The rate of reaction may be expressed as a change in the amount of a reactant or product per unit volume in a unit of time. Usually the volume is constant. Therefore, the rate can be expressed in terms of the change in concentration per unit time. Here is the expression for the average rate and instantaneous rate. The rate is equal to the change in the mole of the reactant or product per unit volume per unit time. The plus or minus sign, we use the plus when we measure the change in the product, and we use minus when we measure the change of the reactant, because by convention the rate should be a positive number. Therefore we put the minus before when we calculate the rate based on the reactant concentration. And the instantaneous rate is the limit when the density becomes infinite small. Is the rate at any instant time. There are some important factors affecting the rate: the reactant concentration, the temperature, the pressure, and the presence of catalyst. Today our experiment is to measure the reaction rate and study the effect of reactant concentration only. So the effect of reactant concentration may be expressed in terms of the rate law or the law of mass action. The rate law states that the rate of reaction will proportional to the concentration of the reactant raised to some exponent m and n. The k is the rate constant, which is the constant at a given temperature. The exponent m and are the reaction order with respect to A and B. M plus n is the overall order of the reaction. For simple or elementary reaction, the order are equal to the stoichiometric coefficient. However, for complicated or multi-step reaction, the orders or the exponents are generally not related to stoichiometric coefficients, so they should be determined based on the experiment. So in this experiment, we will examine the reaction, the decomposition reaction of sodium thiosulfate in acidic environment. We choose this reaction because the product is sulfur solid, and we can observe the formation of the product, so we can measure the rate of this reaction. How to measure the rate and compare the rate at different conditions. So we keep the density constant, for example, of the product, in this case is solid sulfur, by keep the same turbidity of the final mixture, because the product its solid form. To ensure its initial rate, the turbidity of the final solution should be as slight as possible. So when we keep the density constant, so now the rate is inversely proportional to the time taken to reach the same turbidity. So just comparing the time, we can compare the rate at different conditions, and we can obtain the reaction order. In order to obtain the reaction order, we use the method of initial rate. The method of initial rate is we alternatively vary the initial concentration of each of the reactant and observe the initial rate. From that, we can obtain the reaction order with respect to that reactant, the reactant that we vary the concentration. For example, if we double the concentration of reactant A and compare the initial rate, right, now the rate will inversely proportional to the time taken. We can obtain the exponent m1. So we can double one more time, so we can get the value of exponent or the reaction order m2, and we can get the average. So we can obtain the reaction order with respect to reactant A. Do it similarly. We vary the initial concentration of reactant B, and we can also obtain the reaction order of that reactant. Now in the practice, so we prepare the test tube and the Erlenmeyer flask as follows. We use the burette to deliver sodium thiosulfate and water. We use the ratcheted pipette to deliver the sulfuric acid into the test tube. So, and then we pour the acids into the Erlenmeyer flask, swirl one time and start the stopwatch. We stop the watch when the mixture becomes cloudy, as slight as possible. We record the time and analyze the data. This is the principle, and see you in the laboratory. Thank you for watching.